Last portion of Chapter 8 is going to be a little lesson on bearings. A bearing is described using north, south, east, and west. Instead of just saying bearing, we're going to use two letters to describe our bearings in this class. The first letter is going to be where we start, and the second letter is the direction in which you go, or which you go towards. You typically start with north and south, or south. And then you move towards east or west. All right, so these are not going to be X and Y axes. They behave like X and Y axes, but we're going to label these north, south, east, and west. And just so you know, each quarter turn is still going to be considered 90 degrees. So if we are here at north and we're going east, remember this is north, south, west, east. And let's just say that my pen is going to represent going up. We are going up towards north. This is where we're starting. We're going to go towards the east. The east is right here. So I'm going to go towards the east. I am going to pivot in the center, which is still considered, I guess, an origin. We're only going 15 degrees. So I am going to go just a little bit past the north mark because I'm going just a little bit towards the east. Let's look at the next one. So for the next one, north, south, west, east. All right, I'm actually going a lot towards the west. So I'm going to be having my pen pointing down, indicating that I'm starting south. And I'm going to go west, and if I go directly on the west line, remember that's 90 degrees. We're going to go about 15 more degrees because that's going to give us a bearing of 105 degrees south and then west. Over here, we're going to start south again. This is a giant move towards the east. So north, south, west, east. So remember, I'm pointing my pen towards the south. I'm going towards the east. Now remember, each turn is 90 degrees, so that's 90 degrees towards the east. That is still towards the east direction going in that motion. That is going to be 180. When I go all the way over here on the west line, remember that's going to be 270. So just a little past that is going to give us a 280 degree east bearing starting from the south. All right, let's go ahead and take a look at this last one here. So for this last one, let me just go ahead and label these. Always a good idea. So I'm north, my pen is starting up. I want to go towards the west, not a full 90 degree turn, just a little to the west for 75 degrees. So there's my 75 degree mark. And you know, I just want to show the direction of this while we get acclimated to this concept. Just going to draw the direction in which I started. I guess you can't see that arrow. Okay, there we go. So it can be written like that, where you notice the letters are separated. If you see down here, we're just talking about general directions. Northeast, southwest, proceeds south, and proceeds west. So again, north, south, west, east. If I want to go northeast 95 degrees, I'm going to start north. A full turn would be exactly 90 degrees. A full quarter turn, just barely past that, is going to be 95 degrees north, southeast, northeast. Southwest, remember we're starting at the west. We're starting on the south. We want to go 65 degrees towards the west, so that direction arrow is going to look like that. Let's talk about this. When you see the word proceeds, that means like carry on or continue. So if I'm starting on the south and I proceed to go south, that's 0 degrees just on the south line. Same with the west. If I'm carrying on going west, that's just going to be a straight line, 0 degrees, 0 movement. Just going to look like that. Okay, let's go ahead and look at some examples. So we are going to do word problems. Remember, these word problems are old SOHCAHTOA stuff. Because we are talking about general direction, we're not necessarily talking about an X and Y coordinate grid. Bearings are actually still used today. They're used in ships and in the air for airlines. Nautical miles are still used. Just so you know, nautical miles are knots that a plane or a ship is traveling. And to convert it to a nautical mile, all you do is take the knots and you multiply it by the time the craft has been traveling. Oh, and that is so off the screen. I'm so sorry. Knots traveled, that's distance, times the time it has traveled has given you a nautical mile. We'll abbreviate that by NM, nautical mile. All right, let's take a look at this example. So when you work these, remember most of these are going to be SOHCAHTOA. Everything is going to start at the origin, but again, remember this is north, south, west, and east. So when we draw this stuff, as you notice, I'll draw it here, and then I might separate it and just draw a right triangle to kind of understand and get a clearer picture. Let me show you what we mean. So a ship leaves port at noon, and it has a bearing of south 29 degrees west. The ship sails at 20 knots. How many nautical miles south and how many nautical miles west will the ship have traveled by 6 p.m.? All right, so a bearing of south 29 degrees west. Remember, I'm south, just a little 29 degrees west. That's going to take me in this direction. The ship started here. It traveled for 6 hours, noon to 6. It traveled 6 hours, and it landed right here, or not landed, but 6 hours later, we know the ship is right here. How many nautical miles south and how many nautical miles west will the ship have traveled by 6 p.m.? Let's just figure out how long it traveled. So remember, noon to 6 p.m., that's 6 hours. Let's figure out how far it traveled by multiplying that 6 by the knots. We know it went 20 knots, so 6 times 20 is going to give us our nautical miles. So that straight line distance, that's going to be 120 nautical miles. And we know that was at a bearing right here of 29 degrees. And they're asking how far it went west and how far it went south. So let me just separate this out. I know this is 120. And I know that this is 29 degrees. So what we have here is a right angle old SOHCAHTOA. Now remember, this distance right here is how far they traveled south. This distance right here is how far they traveled west. And to get those amounts, we're going to analyze what we know. We are absolutely given the hypotenuse. If we're given the hypotenuse, it's going to be one of these guys. It's actually going to be both of these. If you notice this adjacent side, that's going to give us the amount for cosine of 29 degrees. This west, that's opposite, so west is going to be sine. So if I take the cosine value of 29 degrees and set it up to be south over the hypotenuse, which is how far they traveled, which is 120, when I put that into the calculator and solve for south, that's going to give me the nautical miles for that south movement. So I'm going to multiply both sides by 120. So 120 times the cosine value of 29 is going to equal south. I'll put that in the calculator in just a moment. Let's go ahead and analyze west. All right, so remember, west is opposite. So that is going to be sine 29 equals west over the hypotenuse, which is 120. Again, we're going to multiply both sides by 120. So to find west, we're going to type 120 in the calculator and multiply it by this sine value, and that's going to give us how far the nautical miles are west. Let's go ahead and grab that calculator. All right, so first for cosine, all we're going to do is type 120 cosine of 29, and then that's going to be how far they traveled south. So that's going to be 104.954. And remember, that's nautical miles. And now let's go ahead and analyze how far they went west. So that's going to be 120 sine of 29. And that's just going to be 58.177 miles, or nautical miles. And that's going to be the answer for that word problem. There's our distance going south. Here's our distance going west. All right.